All right, so in this video, we are going to derive these sine and cosine functions, and they're pretty complicated questions over here. They're going to involve some chain rule and product rule and those kind of rules in these questions. So let's get started with the first one over here. The first thing before I even derive the function is if I have a square root, I get rid of the square root and I change it to an exponent. So this is going to be t to the power of 1 over 2. This is going to make it a lot easier to derive. And now I can derive this function. So when I'm deriving this function, this 2 is the outermost function. This exponent is basically like, imagine there's a bracket and the square is out there. So this exponent is the first thing I need to derive. So I'm going to bring the 2 down. I'm going to subtract 1 from this exponent. So my new exponent is going to become 1. So I'm not even going to write it down. Don't have to write 1s down. And the inside is going to stay the exact same. Now we're going to do our first chain rule. So how do we do our first chain rule? Well, let's pretend this 2 does not exist, and we're going to derive sine t to the power of half. So we know that the derivation of sine is just cos. And now we're going to do the second chain rule, which is the derivation of the inside of the bracket. So the derivation of t to the power of half is just 1 over 2 t to the negative half. So this is a double chain rule question over here. This can be simplified a bit. This 2 and this 2 can cancel. So I'm just left with sine t to the power of half cos t to the power of half, and I'll move this to the denominator and make the exponent positive. So divided by t to the power of half, we want positive exponents in our final solutions. These cannot cancel because the sine is attached to this and the cos is attached to this. These are not the same function, cannot be canceled. So that would be my final solution for that first one. Let's go to this second one over here. Very similar idea. I want to first get rid of the square root. So I'm just going to simplify it and write it as an exponent instead, and my exponent is going to be 1 over 2. And now I can derive this function. So when I'm deriving this function, I'm first going to bring my exponent down, going to write the exact same thing inside the bracket. And now I'm going to subtract 1. So my new exponent is negative half. And then with the chain rule, I have to multiply by the derivation of the inside of the bracket over here. So the derivation of the inside, the derivation of 1 is just 0. So that disappears. The derivation of cos is negative sine t. And then the derivation of sine squared t. So this is again another chain rule. First thing I'm going to do is bring the exponent down. It's going to become 2 sine t, and then I'm going to multiply by the derivation of the inside, which is basically just sine t. So the derivation of sine t is just cos t. So again, a double chain rule in this question over here. Now again, we can just simplify this a bit. We don't want to have negative exponents, so I can just rewrite this as negative sine t plus 2 sine t cos t divided by 2. So for the 1/2, I just wrote the 2 on the bottom, and then I'm going to write this whole bracket on the bottom as well and make the exponent positive. The third question here, we have 1, 2, 3 functions multiplying by each other. So we're going to use product rule, but we're going to use product rule for 3 functions. So product rule for 3 functions is f prime g h plus f g prime h plus f g h prime. Okay, and f is just your first function. So f is just sine x. G is just sine 2x, the second function, and h is just sine 3x. So f prime is just the derivation of this function here, f, which is just cos x. G prime is the derivation of this function here, which is cos 2x times the derivation of the inside because of chain rule. So the derivation of 2x is just 2. So this just simplifies to 2 cos 2x. And h prime, same idea, derivation of sine 3x is just cos 3x, and with the chain rule, it's times 3, which is just 3 cos 3x. Now we just want to plug all of this into this formula over here. So f prime is just cos x. So h prime x equals cos x times g times h, so times these two, so sine 2x sine 3x plus f, which is sine x. G prime is 2 cos 2x, and then times h, which is just sine 3x. And then we have fg times h prime, so f is just sine x, g is just sine 2x, and h prime is 3 cos 3x. And now we can just simplify this a bit. This first term here will not simplify. There's nothing to simplify over here. But this one, this 2 will just move to the front. But other than that, everything is pretty much the same. You can move the cos to the front if you want to, but it makes no difference. 2 sine x cos 2x sine 3x. And then for this one, this 3 will just move to the front. Sine x sine 2x and cos 3x. And that's my final solution for this one over here. And last question, again, it's going to be a chain rule question. There's nothing that I can really simplify before I derive, so I'm just going to derive this straight away. First thing I'll do is bring the exponent to the front, write the exact same thing inside the bracket, and then I'll subtract 1 from my exponent. So my new exponent is 2, and now I have to multiply by the derivation of the inside here. The derivation of x squared is just 2x. Then over here, it's going to be another chain rule. I'm going to start by bringing my exponent down and subtracting 1 from the exponent. So that's 2 cos x. Then I'm going to multiply by the derivation of just the inside function, which is cos x. The derivation of cos x is negative sine x. And then we can simplify this one a little bit, not much simplification, honestly. X squared plus cos 2x squared times 2x. And here's where the simplification, positive times negative, just becomes negative 2 cos x sine x. And that is my final solution for this one.